In this video, we're going to look at box plots or box and whisker diagrams. And box plots are really useful for comparing two or more sets of data easily, and they represent the data visually. They're really good at showing how spread out the data is. So there's a few different key points that we have on a box plot. We need to locate the lowest value and the lower quartile, the median or the middle value, the upper quartile, and the largest value. And this is good for identifying outliers and to see how closely packed the data is. So what we can see just by looking at this box plot is that this 25% of the data is very close together, whereas between the upper quartile and the highest value, which again is a quarter of the data, is quite spread out. What we would have normally with these as well is a scale underneath these, and it would be a steady scale. So we might have 10, 20, 30, 40, and so on, so that we actually have it it is a graph, so things should be drawn using a steady scale. Quite often these questions will follow a cumulative frequency curve, because what we've looked at already is that with a cumulative frequency curve, one of the things that we've been looking at is to try and find the median. We've also looked at the upper quartile, and we've looked at the lower quartiles. So from that, we can draw a box plot, because our lowest value would be at the bottom of the graph, and our largest value would be at the end of the graph. And then we've got our median, our lower quartile, and our upper quartile values, and we can join those up to form a box plot. So quite often these occur immediately following a cumulative frequency curve. So example 20, the heights of boys and girls in a class are recorded. The box plots for both boys and girls are shown below. Use the box plots to choose some correct statements comparing heights of boys and girls in the class. So the girls are taller on average. Well, we can discount that straight away, because a good way of thinking about average is the median. And we can see that the boys' median is higher than the girls' median. In fact, every value of the boys is higher than the girls. So the tallest boy is taller than the tallest girl. The upper quartile for the boys is taller than the upper quartile for the girls. But generally, if we're talking about on average, we're thinking about mean, median, or mode. And the median here we can see for the boys is higher. So the median for the boys is bigger than the girls. So 1 is wrong. If we go to 2, the boys are taller on average. Well, yes, that would imply that 2 is correct for the reasons that we've just said. So the boys' median is taller than the girls' median. So on average, they are taller. So the girls show less variability in height. So variability, whenever we see that word, we should be thinking about spread or range. So if we look at the girls' range is from approximately 179 all the way down to 134 maybe. So if we take those away, we get 45. So that's the girls. Whereas the boys, if we find their range, they go from 186 all the way down to 136. So that's a range of 50. So the boys have a slightly larger range than the girls do. We could also compare the interquartile range. So those are range. The interquartile range for the girls, we've got 173 maybe for the upper quartile, and the lower quartile is 155. So that's an interquartile range of 18, whereas for the boys, we've got 180 down to 158, which is a range of 22. So again, we can see that the boys' interquartile range is also bigger than the girls. So the girls do show less variability in height. So 3 is right and 4 is wrong. The smallest person is a girl. Is that right? Well, yes, we can see that the smallest girl is 134, whereas the smallest boy is 136. So that is right. And the tallest person is a boy. Again, we could look at the tallest girl is 178, 179. The tallest boy is 186. So that is also true. And example 21, draw a box plot for the data 4, 4, 5, 6, 8, 8, 8, 9, 9, 9, 10, 12. So for this data, we need to identify the lowest value. You can see the lowest is 4, and the highest value or the largest value is 12. We need to work out the median, and to work that out, it's the n plus 1 over 2 term. And we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 terms. So it's going to be 12 plus 1 over 2, which is the 6.5 term. So we look at the 6th and the 7th. So we've got 1, 2, 3, 4, 5, 6, and 7. So the median is going to lie between these two 8s. So we'll do 8 plus 8 and divide by 2, and we get 8 for the median. The lower quartile is n plus 1 over 4 term. So that's 12 plus 1 divided by 4, which is 3.25. So we look between the third and the fourth term, which is the 5 and the 6. So we'll do 5 plus 6 divided by 2, which is 5.5. So the lower quartile is 5.5. The upper quartile is n plus 1 over 4 times 3. So it's 3/4 of the way through. So that's 12 plus 1 over 4 times 3, which is 9.75, which is between these two 9s. So we can do 9 plus 9 divided by 2 to get the upper quartile to be 9. Now what we need to do is draw a straight line, a number line, and then mark these values on. So I've drawn my number line, and now we put on the values. The lowest value is 4, and then the lower quartile was 5.5. So we'll draw a line between the 5 and the 6. The median was 8. The upper quartile was 9, and the largest value was 12. And we need to put a box around the lower quartile and the upper quartile, and then we draw a line from the upper quartile to the largest value and from the smallest value to the lower quartile, and that's our box plot.